Hi folks, welcome to this video on alcohols. So here what we're going to talk about is formula. We're going to talk about how to name these alcohols and then also how to draw them. So you can see the structural diagrams right here for different or various alcohols. So one is methanol. What's important to note is the beginning, the meth is referring to one carbon in the chain. And if you look over here, there are two carbons in the chain, so that would be eth. And where do you find that information? In your data booklet under the table of alkanes. And so that is actually going to tell you which carbon chain you need to use when you name your alcohol. But another thing to note is the ending of these end in OL. So alcohols end in OL. So if you take a look over here on your chart, you'll actually see that the formula is a hydrocarbon bonded to a hydroxyl, and that's the OH. So the names of alcohols end in OL, so ethanol, methanol, propanol, butanol, okay? And these are called a hydroxyl group because they have a hydroxyl attached to them. Okay, so hopefully we can move on and you'll develop some understanding throughout this video. So basically what happens is we have to go through some of the naming rules. And so when we're naming these, we want to drop the E. So drop the E and add, instead, we want to add this OL. Okay, so but we have to look at first the number of the OH location, so the hydroxyl location. So in this case, it's methan 1 because this is carbon number 1. But if I look here, we have carbon number 1, 2, 3. So it's actually located on the second carbon in this chain. So the second carbon here, that's where this OH is located. So now we have to call it prop 2 or propan 2-ol. Now, why was it propan, or would it have been propanol? Why would it be prop? Because 1, 2, 3 carbons on your table of alkanes is going to represent prop. Meth is 1, prop is 3. If I want to add another one, ethanol, eth is 2. Okay, butanol, but is 4, means 4 carbons. And this 2 here represents the location of the OH. So bonded. So in this case, the OH is bonded over at carbon number 1. So we're going to number them closest to the OH. So that would be 1, 2, 3. Instead of going 1, 2, 3 this way, we put a box around that. Our hydroxyl is closest to this side, so we'd start counting from there. Propan 1-ol, as that's what it ends with. Hopefully that makes sense. That's the naming rules. So again, we'll do some practice in class that should help clarify some of this for you a little bit. So I have some stuff here, but the slide just doesn't seem to be working. This is just adding, drawing some stuff and adding these structural diagrams, but it's not showing up very good. So I think I'll just move on to general properties and we'll do some additional examples in class and such. So anyways, alcohols, we'll just talk a little bit about their general properties and such. So things that you'll want to know, because you will have to know this stuff, say in quizzes and unit exams and your departmental exam and such. So one thing to note about alcohols is, so beer contains ethanol, so it can be used in beverages. It's made from fermented grain, and alcohols can actually be used as an alternative fuel source. So basically the carbon dioxide taken in by the grain during photosynthesis, or as another thing, the carbon dioxide taken in during photosynthesis is equal to the carbon dioxide released when the alcohol is burned as a fuel source. Therefore, we would call this carbon neutral because there's no net gain in carbon dioxide. So carbon neutral is actually a really good thing if you think about global warming and carbon dioxide being one of our greenhouse gases. It's actually really good that we can use these and they can be carbon neutral. Okay, so anyways, moving on. So just a few other things, few alcohols and some of their uses. One that we talk about is methanol, and methanol can be used as solvents, fuels, production of pharmaceuticals, disinfectants. Ethanol right here can be solvents, fuels, alcoholic beverages, so like beer, like I said, production of pharmaceuticals and disinfectants, so very similar to methanol. And glycol as a solvent and isopropanol can be used as disinfectants. So you'll want to know some of those properties. You'll also want to know how to name. But so say for example I was going to draw, I'm just going to draw you an example on the bottom of a structural diagram for an alcohol. So if I was to give you this name, and I might write it a little bit different, but let's say I call it 2-butanol, and I want to draw this structural diagram. So what I'm going to start with is I'm going to start by bute. I'm going to write my carbon chain, or I'm going to draw my carbon chain. So all single bonded, and I'm going to have bute means 4 carbons. Okay, and now this 2 here is actually going to represent, this 2 is going to represent where my my hydroxyl is going to be located. So if I number these 1, 2, 3, 4 from left to right, I'm actually going to put my branch right here. So I'm going to have an O and an H branched off, which means that all the remainder would actually be hydrogens all the way around here. Okay, so I can keep filling these in, and I have my 2-butanol. Remember, these carbons can have 4 bonds around them. Now, another way to write this would be to write it, and I shouldn't capitalize that, sorry, but it would be butan 2-ol. Okay, so hopefully that makes sense. So I have to look at my parent chain, draw my parent chain, look for the number, and that's going to be the location of the hydroxyl because it's an alcohol. Okay, hopefully that helps. If you have any questions, you can ask in class or you can email me and such. All right, so anyways, we'll see you on the next video.